Believe it or not, there is some controversy in the quadrilateral world. The controversy stems from the definition of what makes certain quadrilaterals what they are. If we look at this first quadrilateral, it looks like it should be a parallelogram, but if we are given no information, the only thing we can conclude is that this is a general quadrilateral. It has 4 sides. It might be more than that, but without any more information, this is all that we can conclude. If we take that same quadrilateral and we are given that one pair of sides is parallel to each other, then we can conclude that this quadrilateral is a trapezoid. It might be more than that, but at a bare minimum, it's a trapezoid. The question is, does it lose being a general quadrilateral when it becomes a trapezoid? Well, kind of like when we talked about equilateral triangles and isosceles triangles, when this general quadrilateral becomes a trapezoid, it doesn't lose the fact that it was a general quadrilateral. Just like an equilateral triangle is isosceles, a trapezoid is also a general quadrilateral. Now here's where the major controversy comes into play. If I take this quadrilateral with one pair of given parallel sides, and I'm given that this second pair of sides is also parallel, I can conclude that this shape is a parallelogram. The question is, does it lose being a trapezoid when it becomes a parallelogram? Well, according to our book, a trapezoid has exactly one pair of parallel sides. So according to our book, this shape is not a trapezoid. That definition is an exclusive definition. We're going to use the inclusive definition, kind of like an equilateral triangle is isosceles. A parallelogram is also going to be a trapezoid. We're going to use the definition that a trapezoid has at least one pair of parallel sides. If it has more than that, then it just happens to be a parallelogram also. This definition is the inclusive definition, and it's the definition that we're going to use in this class. So this shape is a parallelogram, it's also a trapezoid, and it's still a general quadrilateral. Since we are using the inclusive definition, this shape is all of these things. Using the inclusive definitions, we can come up with a quadrilateral family tree. The granddaddy of all quadrilaterals. All quadrilaterals stem from this quadrilateral is a general quadrilateral. Just a normal 4-sided shape. Now if we take that quadrilateral, that 4-sided shape, and we set one pair of sides parallel to each other, we get the first branch in our family tree. That first branch is the trapezoid. The second branch is when we have a shape that is, in addition to being a general quadrilateral, a kite. A kite doesn't have any parallel sides, but it does have 2 pair of congruent sides. Now if we branch the trapezoid and we set one pair of the sides of the trapezoid congruent to each other, we have an isosceles trapezoid. And if we take that trapezoid and we have 2 pair of parallel sides, we end up with a parallelogram. Now if we branch the parallelogram and the isosceles trapezoid together, if we take everything that makes a parallelogram and combine it with everything that makes an isosceles trapezoid, we get a rectangle. So a rectangle has all the properties of a parallelogram and all the properties of an isosceles trapezoid. And if we combine the kite and the parallelogram, if we have a shape that has all the properties of a kite and all the properties of a parallelogram, we end up with a rhombus. And finally, if we combine all the properties of a rhombus and all the properties of a rectangle, we end up with a square. This quadrilateral family tree is a quick and easy way to remember how all the quadrilaterals relate to each other. The key to reading this family tree: if we connect going up from one quadrilateral to another, that quadrilateral is always everything above it. If we connect going down, that quadrilateral is sometimes the next quadrilateral. So if we look at a square and a rectangle, to go from a square to a rectangle we have to go up. So a square is always a rectangle. But to go from a rectangle to a square, we have to go down. So a rectangle is sometimes a square. If we look at a rhombus and a kite, to go from rhombus to kite, we have to go up. So a rhombus is always a kite. But a kite is sometimes a rhombus. If we look at a rhombus and a trapezoid, a rhombus is always a trapezoid, and a trapezoid is sometimes a rhombus. How about the rhombus and the isosceles trapezoid? Well, the only way I can get from the rhombus to the isosceles trapezoid is to zigzag. Either I have to zigzag up to parallelogram, then rectangle, then isosceles trapezoid, or zigzag from parallelogram to trapezoid back down to isosceles trapezoid. Either way, I have to go down. So is a rhombus an isosceles trapezoid? Sometimes. Is a rhombus an isosceles trapezoid? Sometimes. Is an isosceles trapezoid a rhombus? Well, I can go down from the isosceles trapezoid branch and get to square, and I can go down from the rhombus and get to square. So an isosceles trapezoid is sometimes a rhombus. If you look at the square goes up to everything. What does that tell you about the square? Well, the square has all the properties of everything above it. So a square is always all the other quadrilaterals. If we look at this branch right here from parallelogram, a parallelogram branches to a rhombus and a rectangle, and then those branch to make the square. So underneath the parallelogram, rhombus, rectangle, and square, these are the shapes that are always parallelograms. If we look at the kite branch, kite, rhombus, square, this branch are always kites. Learn the quadrilateral family tree, and it will help you learn all the properties of all the quadrilaterals.